In about 20 years, the Space Weather Prediction Center has issued a Level 4 geomagnetic storm watch alert.
So scientists, some, are sounding the alarm on a so-called solar superstorm that could, and this is important, underline the word could, eventually wipe out the internet for weeks or even months.
Scientists are raising concerns about a looming solar superstorm set to hit Earth in 2024, a year earlier than previously predicted. This isn't the plot of a sci-fi thriller, but a real threat based on new insights into the sun's behavior. With the power to disrupt satellites, communications, and even the very fabric of the internet, this solar event could plunge our world into a state of unprecedented chaos. So, what measures can we take to mitigate the effects of this massive solar storm? Join us as we unpack this stellar forecast that has got the scientific community and tech world on high alert: the sun's explosive power unleashed. Recently, our sun let out a huge burst of energy called a solar flare. It was the strongest one in 7 years. Solar flares are like powerful explosions that happen on the sun's surface. They send out bursts of energy and radiation. These flares can affect life on Earth by messing with things like power grids and GPS. They can even affect spacecraft and astronauts, but they also create beautiful auroras in the sky near the poles. The most recent flare was part of a series, and it was classified as an X6.3 event. This classification depends on how bright the flare is in X-rays. There are 5 classes of solar flares, with X being the strongest. Each class also has 9 subdivisions, from 1 to 9. The flare we're talking about wasn't as huge as the ones in September 2017, which were X9.3 and X8.25. Solar cycles are periods when the sun's magnetic field flips completely. One cycle lasts about 11 years. We're currently in cycle 25, which started in 2019 and will probably last until 2030. The cycle affects how active the sun is. When it's calm, we see fewer solar flares and sunspots. But during solar maximum, activity peaks, and we see more flares and sunspots. Solar flares shoot out particles that take about 2 days to reach Earth. They can create auroras, even far from the poles during big events. Flares and coronal mass ejections can be a problem for humanity. High-speed solar winds from coronal holes and gaps in the sun's magnetic field can mess with our technology and cause disruptions on Earth. Separating hype from reality, some people talk about solar storms like they're the end of the world, but experts don't think they'll cause major disasters. Yes, they might mess with our power grids and communications, especially in 2025 when the sun's activity peaks. But it won't be doomsday. As solar cycle 25 reaches its peak, we can expect to see more solar flares and coronal mass ejections, CMEs. These events can interfere with radio communications and GPS navigation, while CMEs can impact Earth's magnetic field and potentially cause geomagnetic storms. These storms could lead to power outages and damage to satellites. It's important to be aware of these possibilities and take precautions, such as having backup power sources. However, it's crucial to avoid panic. NASA and the National Oceanic and Atmospheric Administration, NOAA, regularly update us on space weather. They actively monitor the sun, providing reliable information. Sometimes electronic satellites may go offline or experience voltage surges, leading to blackouts in certain areas. Scientists still have limited data on these solar phenomena, making it challenging to predict when the next geomagnetic storm will occur. One notable event occurred in July 2012, when we narrowly avoided a powerful solar storm by just 9 days. Solar storms result from events on the sun, such as solar flares and coronal mass ejections, which send energy and magnetic fields toward Earth at incredible speeds. When these storms reach us, we may see northern lights near the Arctic Circle, but they can also disrupt satellites and electronic communications. Solar storms start with explosions on the sun, followed by energy and radiation reaching Earth. This can lead to radio blackouts, GPS errors, and damage to satellites. Geomagnetic storms can cause massive power outages, impacting daily life globally. How geology shapes solar storm resilience. Solar storms are fascinating, but they don't affect all places on Earth in the same way. Recent studies show that geology plays a big role here. To understand why, let's go back a long time when the moon wasn't even around yet. Around 4.6 billion years ago, our solar system was quite different. Many new planets were forming around the young sun. Planets like Earth, Venus, and Mars were still wandering through space. In the 1970s, an astronomer named Donald R. Davis came up with a theory. He said the moon was created when another planet, about the size of Mars, collided with Earth around 4.5 billion years ago. He called this planet Theia. It's hard to imagine how big this impact was, even with today's technology. Davis suggested the giant impact hypothesis. This theory says that after the collision, the outer rocky layers of both Earth and Theia were thrown into space, forming a ring of debris. From this debris, the moon we know today was formed. The Earth's core likely absorbed Theia's iron core, assuming it had one, and our planet took its current position in the solar system. This made Earth more vulnerable to geomagnetic storms. For a long time, we didn't know much about what happened to Theia after the collision, but recent discoveries changed that. Scientists found evidence that parts of Theia are hidden deep within Earth, under layers of rock the size of continents. This also explains why the moon is dry and lacks a substantial iron core. Now, why does geology matter when it comes to geomagnetic storms? Well, it turns out that the type of rocks under a city can determine how well it copes with powerful geomagnetic storms. For example, sedimentary rocks, which have more water-filled spaces, are good conductors of electricity. On the other hand, denser rocks have more resistance. During electricity disturbances caused by solar storms, residents of the New England Highlands face a higher risk of major disruptions compared to those in the mid-Atlantic coastal plain, all because of what lies beneath their cities. We learned about the severity of these storms from past events, particularly the famous Carrington event of September 1859, named after the astronomer Richard Carrington, who witnessed its breathtaking solar flares. The power of the Carrington solar storm was unprecedented. It caused the northern lights, visible as far south as Hawaii. On that fateful morning, Carrington, at his private observatory near London, observed massive dark spots on the sun's surface, followed by intensely bright areas bursting with white light. These anomalies lasted only a few minutes, but had far-reaching effects. Telegraph communications worldwide began to malfunction, with machines sparking and even causing fires. Bright auroras lit up the night skies globally, confusing birds into chirping at odd hours, and some people mistook the auroras for dawn, starting their day prematurely. Today, with our planet interconnected through vast information networks, the impact of such a solar storm would be even more chaotic and disruptive. The Carrington event's shocking impact. In the 1800s, the telegraph system, like the Victorian internet, was a crucial way to send news and private messages. Even in the United States, telegraph operators noticed disruptions during thunderstorms and northern lights. However, the Carrington event in particular caused unprecedented effects. Many telegraph lines in North America stopped working, with one manager in Pittsburgh noting that the currents were so strong they risked melting the platinum contacts. For instance, a telegraph operator named Frederick W. Roy in Washington, D.C., was injured when his forehead touched a ground wire. Studies of ice core samples suggest that the Carrington effect was twice as powerful as any other solar storm in the past 500 years. Imagining the impact of such a storm today is challenging, but a 2008 report from the National Academy of Sciences estimated potential damages between $1 trillion and $2 trillion. However, there are steps individuals can take to reduce damage, like getting a generator or installing backup energy sources, such as solar panels or wind turbines. Surge protectors connected to electrical panels can also safeguard against lightning and power surges. A simple but effective measure is to unplug devices not in use, as they can't be affected if they're not connected to power. The Carrington event was first observed by British astronomer Richard Carrington in 1859, marking the discovery of the most massive solar storm ever recorded. This event caused stunning auroras visible from the equator to the poles, with some areas experiencing daytime-like brightness at night. Beyond the mesmerizing lights, the surge in electricity disrupted telegraph lines, causing machines to send messages without batteries or even spew sparks. Today, there's concern about potential devastating solar storms, with predictions of another significant event in 2025. Given our heavy reliance on technology and electricity, such a storm could be catastrophic, disrupting power for millions and causing extensive damage. Solar events like flares and coronal mass ejections emit radiation and particles particles that can overload power systems, disrupt satellite operations, and have lasting effects on our DNA. To mitigate these risks, developing resilient technologies and proactive measures against solar storm impacts is crucial, given our interconnected global systems and reliance on complex electronic networks. Researchers are developing new materials and technologies to protect electronic components from the harmful effects of solar radiation. Satellites and spacecraft can be equipped with radiation-hardened components to endure solar storms. Strengthening power grids can also reduce the risk of widespread outages. An important step is enhancing our ability to forecast solar storms. Current prediction models rely on sunspot and solar flare observations, offering only short-term forecasts. New approaches combining ground-based and space-based observations with computer simulations could yield more precise and timely predictions. This advanced forecasting would afford us more preparation time to mitigate the impact of solar storms effectively. Preparing for the impacts of solar flares. Enhancing our ability to predict solar activity is crucial, but equally important is fortifying our infrastructure to withstand and recover from the impact of significant solar storms. This entails bolstering backup power systems, establishing alternative communication networks, and maintaining stockpiles of essential supplies. With strategic planning and preparation, we can minimize the repercussions of a major solar storm and ensure the uninterrupted functioning of our economy and society. Solar storms, though posing considerable risks to our modern way of life, can be managed effectively through diligent planning, research, and investment in resilient infrastructure. By taking a proactive approach, understanding the potential hazards, and readying ourselves to confront whatever challenges the sun's activity may bring, we can continue to reap the numerous benefits that solar energy provides. As solar activity nears its zenith, anticipated around the end of 2024, experts caution that the approaching solar maximum could be more formidable than anticipated. While the sun may appear serene from afar, a closer look reveals its dynamic and volatile nature. Its surface oscillates between a serene expanse of fiery energy to a turbulent sea of plasma, undergoing these transformations in a cyclical rhythm every approximately 11 years. During these peak periods, the sun's magnetic field becomes intricately entangled, akin to a tightly coiled mass of rubber bands, before abruptly flipping polarity, turning what was the North Pole into the South Pole, and vice versa. Preceding this magnetic upheaval, the sun intensifies its activity, ejecting massive bursts of plasma and emitting powerful radiation. This phase, known as solar maximum, marks a precarious time for Earth. Solar storms, an inherent risk during solar maximum, can wreak havoc on our technological infrastructure, disrupting communications, jeopardizing power grids, and even endangering astronauts and satellites in space. Recent observations of heightened sunspot activity and rare solar phenomena suggest that the current solar cycle might peak earlier than initially projected, possibly by the end of this year. While historical data indicate that an average of 185 sunspots per month during solar maximum is manageable, the potential impacts underscore the importance of preparedness. The accelerated timeline of solar activity necessitates swift action in fortifying our defenses and implementing contingency plans to mitigate the potential fallout from these celestial events. What do you think about the upcoming solar storm? Let us know in the comments, and hit like and subscribe to stay ahead of this historic event.